Okay, these are going to be the solutions to the various parts of the October 28th, 2024 assessment. These will solve every question on this assessment, whether it's a question you signed up for or not. So this is every prepared question in one massive test, so it'll be a bigger test than anyone actually writes. We will start a new attempt. And here we go. We want to expand and simplify 2m plus a negative 4n, and we want to square that. This is the product of perfect squares, so we're going to have to start with this squared and end with this squared. And in between, we're going to have that 2ab. So this is the a plus b all squared equals a squared plus 2ab plus b squared. So we're going to start with a 4m squared. We're going to finish with a positive 16n squared, because this negative 1 squared becomes positive. Now for our cross term, we are going to have one. It's that 2ab, so we could eliminate option C here. We're down to a and b, and we have a negative 8. We have two of those. So this is that 2ab term. Next, we want to solve for the missing exponent m. Well, we know that 5 times 4 is 20. No issues there. So m times 4 has to be a negative 48. That can only happen if m is negative 12. We just take a negative 48 divided by 4. Now to solve for this missing exponent, again, we don't really have to worry about the 9s. That 3 times 5 is 15. The 9s are taken care of. We need to look at the exponents of 11. So 5m equals a negative 70. That means m is negative 70 divided by 5. That is a negative 14. Now, which of these expressions represents a negative number? Well, it's not going to be a. This will be a positive 1/3. It's not going to be a b. It's going to be 1 over 8. If you weren't sure about that, remember the negative just takes something in the numerator and flips it to the denominator. If you don't remember that, you can at least look at this and say, this is a positive number raised to a negative exponent. We're only going to have one answer. So if one is negative, so is the other. So they can't both be negative. So we're down to C and D. C, the negative is not contained within the brackets. D it is. So if it's contained within the bracket, we're squaring that. So it's not the negative of 3 squared. It's negative 3 times negative 3. Negative times negative is positive. So this is a positive number. This is our negative. 3 to the 0 is 1. This equals negative 1. Now, expanded form of this one, multiplying polynomials. So this would be a and 4. Actually, it's worth going through that with everything now that I think about it. Multiplying polynomials, that's a and 4. Integer and rational exponents, a and 3. Integer and rational exponents, a and 3. And this is also integer and rational exponents, a and 3. So the expanded form of this, well, we're going to need our values of a and c. A is our cubed term. The only way to have cubed is if we take the squared, multiply it by the 1. So the 2x squared times x gives us 2x cubed. C is the coefficient of x, that's linear. So we need 1x in each. So we have the negative 4 times a negative 4x, which makes a positive 16x. X times 1 is 1x, positive 16 and 1 is 17. So this, again, was multiplying polynomials. All right, now we have 3 linked questions dealing with numeric square roots. So these are a and 1. So written as an entire radical, 8 times the square root of 9 is root a. What's the value of a? Well, the entire radical is when you bring everything inside. So it's 8 squared times 9, or 64 times 9. Well, 8 squared times 8 is 512. We're going to have another 64 on top of that. So 64 plus 512 should be 576. We see there's a typo there. 576. All right, part B. So the values of B and C, when we write this as a fully simplified mixed radical. So 704, we're going to have to reduce this. So let's get a calculator out here. We need to make sure it's on the right desktop. We are looking for cube factors of 704 to simplify it. Well, 2 cubed is 8. Goes into that 88 times. Leaves us with another 8. And then we're left with 11. So C is going to have to be 11. We pulled out 2 factors of 8. When we take them out from under the cube root, those 8s become 2. So this is 2 squared, or 4 on the outside, and 11 on the inside. So again, that's AN1 for our perfect squares and cubes. And if memory serves, 5 and 6 are scored at half a mark each because it's really one problem that has 2 parts. Now here we have a written response. I plan to say this in class explicitly on Monday, just in case I forget. Anytime we are doing written response on SmarterMarks, the written response are not machine scored. So you will not see any score until I get in there and manually score it. When we see the score at the end, I'm going to wait until everything is submitted. We will actually see the mark is not final, it needs to be scored. So here, we want a fraction that falls between the square root of 10 over 17 and the square root of 50 over 67. Well, 10 over 17 is about 4.12. Oh, that only took the square root of 17, not just 10. All right. Let's try this. 10 over 17, and then I hit equals. There we go. Now we take the square root. It's about 0.7669. Next is the square root of 50 over 67. Take that square root. Now we've got a 0.863. So a decimal between those would be 0.8. And 0.8 is the fraction 4/5. If we want it to look prettier, we can hit the equation, use a fraction, and write our 4/5 this way. So 4/5 is far from the only answer. What matters is we find a fraction whose decimal representation is between this 0.76696, yada, 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 and our 0.863868, and so forth. Now, a decimal that falls between negative 0.2 and negative 0.1. You can go negative 0.115 or even 15, which is what I was thinking. I typed an extra 1. Now, finally, 3 over 4 and 4 over 5. Putting them over a common denominator of 20, we have 15 over 20 and 16 over 20. So a number between those would be 15.5 out of 20. But it's horrible, horrible form to actually mix decimals and fractions. If we multiply top and bottom by 2, we get a 31 out of 40. So 31 out of 40 will be between these two numbers. These are all working with rational and irrational numbers. That is AN2. Now this number, 264,600, can be factored as 2 to the A, 3 to the B, 5 to the C, 7 to the D. And how many of these are there? 600. We're going to divide that by 2. We have one of them, still even. 2, 3. So we have 2 to the 3. And then we get an odd number, so we know it stops. Now, 33075, divide that by 3. It works. We could check our divisibility rules where we divide numbers by 3. That's also a multiple of 3. Also a multiple of 3. Now, this adds up to 10. Right, 1 plus 2 is 3, 5, 5. So this is no longer a multiple of 3. So we divided by our 2's, and then we just check. We had 1, 2, 3 3's. Divided by 5 once, twice. And hopefully at this point, everyone can recognize that 49 is 7 squared. Okay, so that was obviously AN1 prime factorizations. Maybe I shouldn't say obviously, but that is AN1 prime factorizations. Now this one, when we expand it and simplify it, what values do we have? Okay, so we need the 2x, the 3x plus 4, and the 4x minus 2. Okay, so this is probably going to be a terrible whiteboard, but it should get the job done. Let me see if I can get it to work with... I have a writing tablet, but it doesn't seem to be recognizing it. Okay. So we have 2x, 3x plus 4, times 4x minus 2. This equals 2x. 3x times 4x. 3 times 4 is 12. They each have an x, so that is x squared. 4 times 4x is a 16x. 3x minus 2 is negative 6x. And then 4 minus 2 is negative 8. So we still have a 12x squared. Combine these to make a minus 10x. Oh, sorry, a positive 10x for the 16 minus 6. Minus 8. And yes, we need all three of these, so we are going to multiply it out one more time. So it's 24x cubed plus 20x, or x squared, sorry, 1x inside, 1x outside. Finally, minus a 16x. So in our ABC form, ax cubed minus bx squared plus cx. This is giving us an x squared. Yeah, the simplified form is negative, so this should be 24 minus 20 minus 16. We don't have the sign for a negative. It should, I guess we're just looking for the absolute values. Okay, I will make that correction to the question before I put this out. This is one of the reasons I always write the tests before they go out for distribution. I am just going to reload on my answer key page and make sure that that is what we're looking at before we go on. Yes, these are the answers it was looking for, so I have to make sure that those signs get flipped properly. Okay. Number 11. So we are back into AN4 on multiplying polynomials. That's what we just finished. And actually, if I remember correctly, these are also scored as 0.33, 0.33, and 0.34. Now, 11. When the expression 4x plus 7 times x squared plus 2x minus 7 is expanded and simplified. Here we just want the x squared term. We're going to have that from 7 times x squared, which is 7x squared, and 4x times 2x, which is 8x. With 7 plus 4, the coefficient is 15. We don't need to put the x's here because we were just asked for the coefficient, not the leading term. And it's not even the leading term, I guess, because that would be the x cubed term that we didn't have to worry about. All right. In the area of a rectangle with length 9 minus y and width 3 minus y is. So again, we are multiplying polynomials. 9 times 3 is 27. Minus 3y minus 9y is a minus 12y. That's the only thing that matches. Yes, the minus y times minus y is a plus y squared. But when we got to the 27 minus 12, we could have said, this is it. That's the only one that hits that point. Now, for the numbers 56 and 40, we want to find the greatest common factor. So these are both multiples of 8. So our calculators can do the greatest common factor algorithm for us as well. We can always subtract and use the Euclidean algorithm. 56 minus 40 is 16. 40 minus 16 gives us 24. 24 minus 16 is 8. 8 minus 16 is 8. 8 minus 8 is 0. A number minus itself, that is the greatest common factor when we get down to 0, using the Euclidean algorithm. Now again, using our calculators, well, 56 is 8 times 7, 40 is 8 times 5. So this has to be the product of the two numbers divided by the greatest common factor. So that's the same as 56 times 40 all over 8. 56 times 5, because 40 over 8 is 5, and 56 times 5. 50 times 5 is 250, 6 times 5 is 30. That one should be 280. All right, we want to solve for m in this equation. Here it gets a little bit hairier. So this one, I'm going to start a new canvas here, just so we have room to work. So looking just at the exponents inside. The numerator here is m minus 18. And the denominator, the exponent is 7. Make sure that looks like an 18. We have a 4 here. And that is going to be a negative 128. So here I'm just writing the exponents themselves because we're going to add, subtract, multiply, and divide with these rules. So we are going to have 4m minus 72 all over 28 is a negative 128. Now, when we're multiplying these, this is not necessarily a negative. Oh, yeah, it is the negative 128 plus the 28 when we bring that x to the 28 up across. We're doing x exponent 28 times x exponent negative 128. So this gives us 4m minus 72. We add a positive 28 to a negative 128. We get negative 100. We add 72 to both sides. And that's a negative 28. Divide by 4. And m is negative 7. If Smarter Marks does not allow you to enter a negative number, that means the correct answer does not contain a negative number. So that is worth noting. Just rechecking the answer key. I always do these myself as a trial. And yes, so far every machine scored question has been marked correct. So which of these is the simplified form of the cube root of 108? We have to look for cubic factors of 108. So 108 divided by 2 cubed. 108 divided by 8, not a whole number. 3 cubed is 27. That is a factor. So if 3 comes out, what we are left with is the cube root of 4. So this is 3 times the cube root of 4. Push comes to shove. You can always type all 5 of these numbers into your calculator and see which 2 match. Oh, and that was squaring cube roots again. This one was exponents. This is also exponents. So if we have m plus 6 equals 12, m is 6. All right, and now we are left with our last written response. So is the square root of 3 rational or irrational? It is irrational. I believe this is scored out of 1, and identifying whether it's rational or irrational is half a mark. How do we know? It's a non-repeating, non-terminating decimal. We could also say, the way it's actually formally proven mathematically, if we do a new one, let's say it is rational. That would mean the square root of 3 can be written as a fraction. So that means in some form, it can be written as P over Q. It's not a problem to assume that this P over Q is written in simplest form, that there's no common factors. We've reduced it in its entirety. So that means if we square both sides, we have P squared over Q squared. Multiply both sides by Q squared. We have this 3Q squared equals P squared. If this left-hand side is divisible by 3, it's 3Q squared, the right-hand side must also be divisible by 3. So that means for some K, P is 3 times K. With that substitution, we can write 3Q squared is 3K all squared, or 9K squared. Divide both sides by 3. And now we have Q squared is 3K squared. But if the right-hand side is divisible by 3, so is the left. So our Q would be 3 times, say, M, some other number. But wait, we have a contradiction. That means P and Q each have a factor of 3. But we said we could write it as a reduced fraction. This is what we call proof by contradiction. We made one assumption, that the square root of 3 was rational. That means we could write it as a fraction. We followed that with no additional assumptions until we get a logical contradiction. That our reduced fraction that we had in the beginning can't be reduced because they both have factors of 3. So that is how a formal mathematician would prove that the square root of 3 is irrational. We just have to say it's a non-terminating and a non-repeating decimal, or cannot be written as a fraction. Those two are sufficient. If you can think of a third, I will consider it. It might not be wrong. I will submit these questions as they are. Now we see here, it's not looking good for our AN2. 5 out of 5 for factors and roots, 5 out of 5 for integral and rational exponents, 5 out of 5 for multiplying polynomials, but only 1 out of 5 for irrational numbers. But we have this comment here. Some written response questions have not yet been scored. So if I score these, now everything is scored on my end. If we refresh this page, that's our 20 out of 20. That caveat about some written response questions not being scored is gone. When you are looking at this as a practice test or reviewing it, let's say we want to look at our factors and roots, we can show, and now highlighted in blue, are the questions correlated with that outcome. So the greatest common factor and least common multiple were 1 mark each. The prime factorization was 1 mark. The square root alone is 1 mark. And this 2-part cube root added up to 1 mark. We can look at our irrational numbers. That's these 3 multiple choice, or these 3 written response. This one here, simplified form, so going between mixed and entire. And this irrational. Integral and rational exponents, we can check up which are here. Again, simplifying our exponents. Finally, multiplying polynomials. We can see our 5 questions marked in blue, or the 5 marks marked in blue. And if you're not sure why you got an answer you did, there's the answer key. Okay. So again, another possible example to that last one, a possible solution. We could say that the radicand, or what's under that radical sign, is not a perfect square. That's another acceptable solution. So these are the scored results to the October 28th assessment for Math 10C.